We're going to go over limits, and we're going to talk about what it means to approach a limit from the left or the right side. And we're going to start with a relatively simple example. What we're going to do is in the first part is we're going to create a chart and put out our values so that we can see what we are attempting to do here. So we have y is equal to x squared minus 1, okay? And these are our values for y when we plug in values of x. The question asks us for the limit as x approaches 2. So the idea is we're going to take values that get closer and closer to the value of 2 for x and plug them into this equation to see what they equate. So we're going to start from the left of 2, which is usually denoted as 2 with a negative, where we would normally put an exponent. And that means to approach 2. We'll use an arrow to approach 2. And this means from the left. That says least. There you go. After that, we're going to work on approaching 2. And when we have a positive value, that means approaching 2 from the right. And what we mean by right and left is we want you to think of a number line. Okay? And I'm going to split this up into a couple of values. Ooh, that was not very straight. Okay. We have our value for x and our answers for y. And we'll say this is our number 2. From the right on a number line means numbers greater than 2. So something like 3, and then 2.5, and so on. We come downwards. And from the left of 2 is the exact same idea, just from the other end. So we have numbers like 1, 1.5, and so on. So what we're going to do is we're going to quickly plug these values in to see what we're approaching as a y value when we get closer and closer to our value of 2. So we'll bring up our calculator here. We probably don't need it for the first few. When I plug 1 in for x, 1 squared is 1. 1 minus 1 gives us 0. Perfect. Okay. When we do the same thing for 3, 3 squared is 9 minus 1. You guys are the best. Okay. Calculator. 1.5 squared, 2.25 minus 1, 1.25. So we're moving up. Let's do the same thing with 2.5. 2.5 squared minus 1, 5.25. Okay. This seems tedious to start, but there is a goal for this. As you notice, these numbers are increasing, these ones are decreasing, hopefully aiming for something in the middle. What we're going to do now is, these values we've chosen were rather large. The idea really is we really want to get as close as possible to 2 as we can. So we're looking for numbers that we would normally just round to 2. We are approximately 2, we would say. So we're thinking of numbers much closer to 2. So 1 and 1.5 are close, but we can get far closer. I want you to think of numbers like 1.9, 1.99, 1.999, or 2. Let's say 1? Yeah, I guess so. 2.1, 2.01, 2.001. Okay? So we're thinking of numbers that are infinitely close, extremely, extremely close. So we're going to work with these values now. These are more along with what we're going to be doing for the rest of these. So let's start with 1.9. 1.9 squared minus 1 gives us 2.61. Okay? 1.99 squared. Do the next one. 1.99 squared minus 1. What happened there? How did I get a value that... Oh yeah, that's right. Sorry. 2.96. That's good. 2.96. Okay. Now let's start 2.1. 2.1 squared. Subtract our 1. 3.41. And then 2.01. Oh, wrong button. I apologize. 2.01 squared minus 1 is 3.04. So, 3.04. Using the information we have here, and of course we could use numbers much closer. We could have used something with 9 repeating many times. 2 with several zeros before our 1 to get values that would be even closer to the number we're aiming at. What does it look like we're aiming at here? It looks like we're coming together at the value of 3. And we can actually put the number 2 into this equation. Y is equal to 2 squared minus 1, which is 4, minus 1, which is 3. So our value is 3. Now the reason we want to use this process, because we'll eventually get values that when we plug our number as x approaches 2, as we plug the number 2 into an equation, we might have something that's not continuous. It will not exist there. So what we'll do is approach 2 from different directions to see if they're converging on one specific point, or if we have a function that maybe jumps, okay? And what we mean by that, and we'll go through a couple other examples. We'll bring up another example here, actually. Straight out of your textbook, we had another one. Let's say we had f at x is equal to x minus 1. And I had it in your textbook. Let's pause it while I figure this out. So same idea. We have a little more complex of a function. I've written this a little more like you'll see it in your textbook, and eventually we'll go right to how the textbook writes it. We notice that if I plug in our value of 1, our denominator ends up being 0, right? So that means we have an undefined value here. So this is where this becomes handy, what we've learned. So we'll split these up a little. And we know our x value, or actually at 1, is undefined. Okay? So we have an undefined value for our y. We're going to use values that get much closer. So something like 0.99, 0.9999, and then several of them, which we really don't need to do that many. But 2.01, 2.0001, and 2. Okay, so as you can imagine, we'll do 2 in a row instead of the 3. We'll start here, do the next one. Okay, from the right and the left. This being our left, this being our right. We'll find our values with our calculator here when we plug them in. So when we square these values, first of all, our number on the bottom is going to be infinitely small. We have 0.999. Subtract our value of 1, negative 3 zeros. Okay, and then I need to square this. My calculator isn't a 2-line calculator on this computer, so you could probably do this all in one step. 0.9999 squared minus 1. I think I can do it. Divided by bracket 0.9999 minus 1. End bracket. Does it work? Yeah, I think it works. 1.999. Okay. So we got 1.999. And if we'd chosen this one, it would have been something really similar. Maybe like 8. Okay. Yes. Correction on the positive side here. 2.001 is not that close to 1. We're working with numbers 1.001. Okay, so we'll jump right to our closest value here to speed things up, and I'll try it again on the calculator. 1.00001 squared minus 1 equals divided by 1.00001 minus 1. End bracket equals. Don't think that quite worked out on my calculator. We are going to be getting a value, though, I believe, if you put it into your calculators, of something like this. Okay, so we'll be getting values that are approaching the number 2, but at the number 2 we are, or sorry, at 1, there is no value there for our y. Okay, so we are approaching 2 in this question. Okay. So this idea is approaching a limit or approaching a number from the left and the right is what we're talking about when we're working with our limits in these questions. Let's do a dual page. So if we were to plot something like this, the idea is that our x value would go from 0 to 1 to 2, okay? And our y value here, 1, 2, 3. We have some function at the value of 1 where we'll have a hole, and we are getting closer and closer to 2. And then on the right side of it, if approaching 1 from the right, we're getting closer and closer to the value of 2. being our right, this being our left, but we have a hole in this function. Okay? So this is discontinuous, which is very important for us. Okay? We're just going to essentially incorporate 1.6 into everything as we go through it. So here's another question of a piecewise function. Okay? Now this is important. Determine the limit of f at x as x is approaching the value of 1. And if you notice, we have 3 different equations for this function. So what we'll do is when x is less than 1, okay, this is our equation. So to give an idea of a number like 0.9999, we'll plug in for our value of x into this one. And this is one we could probably do our calculations by our hand here. 0.9999 subtract 1 gives us a value of what? Anyone know? Something very close, or approximately almost 0. Okay? So we're getting a value of almost 0 at the beginning of this. So if I was to try to plot this as we go through it, okay, at our value of 1 here, which is very important, our function is probably increasing to about 0 on our y-axis. Okay? Now, at the value of 1, it says x is 1, which means when I'm actually at 1, my y value is 1. So I'm going to put a point there. Okay? We have a little hole here at 1 for the other part of the function. And finally, the top part, when x is greater than 1. So we're using a value, do this in blue, something like 1.00001, and we'll plug it into this function. So we have 2 plus the root of 1.00001 minus 1 will give us what in this end? This will be approximately 0, so it'll be like 2 plus okay, so we're approximately a value of 2, which means when we go to plot this again, at our value of 2, our function is probably going from here and then increasing. So here, we have a jump. This is a discontinuous function. It is important for us to approach it from both the right and the left in order to figure out that this function was discontinuous. Okay? That's good for